oblique is an angled photo. This is Hungry Harbor, photo point of the culvert on the left. Pre-restoration, it was a 60-inch undersized perch culvert. And earlier this year, we put in a 18 by 12 foot box culvert. Dairy Creek, same idea on Savi Island. We replaced this collapsing double culvert with a channel spanning bridge in 2019. And this one's a little harder to see. It's an orthomosaic of pre versus post. If you can see my mouse pointer over here, this is a squash culvert that was put in and a bridge over here. And we're monitoring, we're tracking change of the vegetation communities after hydrologic reconnection. Virtual site visits. Some of you have been on these virtual site visits. They've been extremely helpful during these crazy times of people not being allowed to go out in the field or not wanting to. So they've been a great alternative. This is a panoramic of Dalton Lake, which was presented to the ERTG as a virtual site visit earlier this year. Now follow me to Hungry Harbor. And I apologize, it's kind of jolty because I had to speed it up in the interest of time. But again, this is pre-restoration. This was flown in 2018. This is that same culvert during construction, winter earlier this year. And that was after construction. And I never thought I'd be video editing for my work, but I do a lot of that now, which is kind of fun. The learning curve was pretty massive, but it's been fun. One of the contractors dared me to do this during construction. I was a little hesitant, but after many tries, I finally got it. And we've been doing snorkel surveys in there pre and post and right after construction. In the lowest pool right inside of the culvert, we saw all these little coho. These shots are all vertical and oblique photos at several sites during many phases of restoration. They're all taken as part of reconnaissance work. Just pretty pictures, but they're also useful. So reconnaissance mapping, or these orthomosaics, and I'll explain what orthomosaics are in the next slide, but they're basically a large photo, a snapshot in time. And the reason they're useful is because the resolution is amazing. The resolution is about 1 to 2 inches per pixel, whereas Google Earth is 1 to 2 feet per pixel. And these orthomosaics are numerous photos all stitched into one. And these reconnaissance orthos are not geo-referenced, meaning that they're not tied to the surface of the Earth. To do that, you have to lay out ground control points, and I'll explain what that is. But ground control points are very labor intensive because you have to scatter them around the site, and especially at large sites, it just takes forever. So these are strictly used for early feasibility work, photo points, and some compliance monitoring. And this is Dairy Creek on Savi Island, which connects Sturgeon Lake over here with the main stem Columbia. And we fly it annually to monitor the sediment movement in this channel. And we've noticed over here by Sturgeon Lake that there's a lot of beaver activity. So this is one photo out of that orthomosaic. And up here you can see a lodge. It's huge. It's like a beaver city. And then over here is the dam, one of the dams. There's several in this channel. And all this bright green is Wapato. And I'd like to show you a better idea of what the resolution's like. This is the dam. You could see individual sticks in here. And I assure you, in floodplain wetlands, you can pick up individual blades of reed canary grass. And again, during these reconnaissance missions or flights, we're taking photos and video. We fly the site to identify areas of potential restoration, track restoration after construction, and also the funnest part about it is scanning the site with video and photos, looking for beaver activity and sediment movement patterns. So while I'm flying, I'm looking for dams, lodges, beaver slides, and shoe evidence, and also evidence of accretion and erosion. This is a geo-referenced orthomosaic out at Government Island, under the 205 bridge. And so to make an orthomosaic, a geo-referenced orthomosaic, you program the drone to fly a grid over a specified area or site, taking pictures at a set interval and set overlap between the pictures. And to georeference the orthomosaic, ground control points, or GCPs, are deployed at varied elevations near areas of interest and just scattered all over the site. And then during post-processing, the photos are stitched together and the GCPs are assigned an elevation, which then you can render out using post-processing software, a georeferenced orthomosaic and a digital terrain model. These layers, they're basically .tiff files that are outputs that you can upload to GIS, which we use for precision mapping of vegetation and sediment maps. And again, this is an individual photo from this orthomosaic. And up here, this little orange X, that's a ground control point. And this is what it looks like on the ground. It's basically a spray painted X. We first map down the vegetation because you have to be able to clearly see this ground control point at several angles with different photos to triangulate for georeferencing. And in the middle of that X, you touch down on it with your RTK to get a very accurate lat long and elevation. And then using the georeferenced digital terrain model, topographic contours are rendered at specific intervals according to the site. The contour lines are overlaid onto orthomosaics and are used to track sediment movement and vegetation, and you can make vegetation community maps as well. The top photo here is just the orthomosaic georeferenced at Hungry Harbor after construction. The one in the middle is the digital terrain model overlaid with the topographic contours. And the bottom is the ortho with the topo overlaid on top of it. This is a Woodland Island, which it was a dredge spoil placement project done in late last summer. So we kind of knew that there was going to be a lot of sediment movement and we wanted to track it. So we built these maps by georeferencing them with ground control points and then overlaying these contours over the orthomosaic. And you can see over here in October 2020, right after construction, there's this peninsula on the left, on the west side of the island. And it was used as a landing strip basically for the dredge pipe. In January 2021, it had mostly eroded away. And also you can see this blue line on top of this anvil structure. This is all dredge spoil again. The blue line is the highest elevation on this structure at 16 feet, NAVD 88. In 2021, there's a lot less blue, so it's slowly eroding away, which we kind of knew was going to happen. And we'll continue tracking this over time. I'll probably fly it again before the rains come, and then this winter again, probably. We delineate vegetation communities using RTK technology, so high precision survey gear during on-the-ground surveys. In GIS, these data are overlaid onto the orthomosaic with elevation contours to make polygons of the varied veg communities. And during pre-restoration, native plant communities are used as a reference for a planting plan or target elevations for construction. And non-native plant communities are identified for prescribed restoration action. During post-restoration, these maps are used to track the vegetation community response to restoration action. So up here, this map is of Dalton Lake vegetation communities. So what we did was, there's this central channel, and there's a water control structure up here. On the east side of this central channel, we delineated with an RTK all these different pockets of different vegetation communities. And then after post-processing and during the map making exercise, we overlaid the orthomosaic, so the snapshot of the site, and on top of it, we put the contours and the survey data. So then on this side, we use the survey data overlaid as a reference to hand draw all these polygons. So this side wasn't really surveyed. This side was. This was all hand drawn based on the survey done on this side. And over here, similarly, we did the same exercise, but also using the contour lines, we delineated these planting zones for the planting plan. Next step. So our drone system is roughly 4 years old, and the technology is advancing quickly. So we're looking to upgrade to a multispectral drone, which will make our vegetation community mapping a lot more efficient and more precise. We also want the new system we get to be RTK enabled, so we can do site scale surveying with less ground control points. And then we'd like to integrate the multispectral imagery with artificial intelligence for map making and GIS. And I'd like to acknowledge these folks and organizations, and I'll open it up to questions if there are any.
Thank you, Narayan. That was fantastic. Lots of great imagery and science. We do have time for questions before George's talk will be next, and I'd like to encourage us to get the discussion started now. And maybe I think what we were doing before is the ERTG gets first dibs on questions.
Kim has his hand up. Yeah, you showed the example of Woodland Island. In the best case scenario, what is the vertical resolution for looking at the sediment accretion or loss? And what's the approximate level of resolution where you have veg on the ground?
So we've done, I'll answer the second one first. We've done some ground truthing when there's vegetation, and obviously it's tree canopy cover. They're like tree cover. There's basically, it's not good at all. But with big swaths of reed canary grass or just emergent veg, it's actually pretty good. It's within a few inches, 3, 4, 5 inches.
Mm-hmm.
And then your first question again, sorry, Kim.
Oh, it was in the best case scenario, such as at Woodland Island, the graph you showed, that at a 2-foot contour line. What's the level of resolution for areas like that where you're really interested in sediment accretion or loss? So you get
Yeah. So I did a 2-foot increment because there wasn't really that much change, but that is completely customizable because when I do the post processing, I set it at 3 inches, and then in GIS is when I kind of change that however I want it. So I could the resolution could be within an inch or 2 or 3. I just did that because then you'll have like 50 lines and it's hard to tell what's
right.
what.
Yeah. But for monitoring, that's pretty high resolution to know, on an annual or a seasonal rate, how quickly things are accumulating or disappearing. Thank you.
Yeah, thanks for the question.
Okay, I don't see any other hands up. Anyone else have a question? Just go ahead and speak, please.
Hey, Narayan, this is Ian with Columbia Land Trust. I was just curious, this is great. And you guys are doing similar stuff, but are more advanced. And I'm just wondering if you guys have written up some of your protocols for doing this work, and could those be shared?
Thanks for the question, Ian. It's a work in progress. Sarah Kidd from Lower Columbia Estuary Partnership, I'm sorry she wasn't able to present today, but we are actively working on protocols for monitoring. And once they're up and running, you'll be one of the first to know.
Sounds great. Thank you.
You're welcome.
I see Amy Bordy has her hand up.
Hey, Narayan. That was a great presentation. It is so cool to see what you are doing. I have a question about the elevation work. I might have missed it, but is it structure from motion? Is that how you're getting the elevation data from the ortho imagery?
Yeah, pretty much. It's derived from point cloud data, which then renders out the digital terrain model, and that's how we get elevation data.
Okay, so I was interested about your answer to Kim's question and the canopy cover, and just trying to understand how that works with when there's emergent vegetation like reed canary grass or something that's pretty dense. How is it getting through that canopy?
Yeah, it's so it's done, the digital terrain model is what does it. It's not rendered from the actual visible photo. It's done with the and you can see where there's vegetation and all of a sudden a channel.
Mm-hmm.
And if you ground truth the elevation of the sediment under the vegetation, it lines up pretty well. But again, there is error. So hopefully with the multispectral technology and the RTK enabled system, we can get rid of, or at least decrease the error there.
Okay, cool. Thanks.
Yeah. I look forward to your presentation, Amy.
Any other questions for Narayan? And if not, we will be having a discussion section at the end where all 3 panelists will be available. Oh, I see 2 hands up, I think. I'm unable to see who they are right now. Can anyone else see any hands up? Sorry.
I don't see any hands, Ida.
Okay. Alrighty, thank you, Narayan. I think we'll move on to George Fornes. Welcome, George. George